Welcome to lesson 2 on vectors and scalars, where I'm going to explain the vector quantities that they describe on page 192. So the first one they have there is a force. Now a force is defined as a push or a pull, and there is always a size and a direction connected to a force, a push or a pull. I think that is rather clear. Gravity is pulling you towards the center of the earth. The chair is pushing up on you, so that would be a normal force. There is a magnetic force of attraction if you have the north pole of one magnet close to the south pole of another magnet. The two magnets will be attracted, so it's a force of attraction. If you are lifting a basket or something, you are lifting it, it's a force of lift. If you are in a tug of war, there's a tension in the rope or the chain. So weight I already mentioned as a gravitational force. Weight is a force. Now we get to the third one, displacement. Now displacement is a change in position. So if I was at point A initially, and I went to point B, it doesn't matter what path I followed to get to point B. That's the path length is distance. That's distance. But at point A you had a GPS coordinate, and at point B you've got a GPS coordinate, and the straight line from point A to point B is the size of the displacement and the direction going from A to B, for example, east. That would be the direction of the displacement. Number 4, they say velocity. Now velocity is the displacement per second or unit time. So I don't know if you can recall, I said that I travel a distance of 9 kilometers and it takes me 15 seconds to get to school. So my displacement from home to school is not 9 kilometers. My displacement is like the crow flies. Okay, that is but 5 kilometers, and it is south of my home. So velocity is used to taking the displacement and dividing it by time. So my displacement is 5 kilometers, and I take 15 minutes, which is a quarter of an hour. So that is 20 kilometers per hour, but there's a direction connected to it. It is south. There's a straight line connected to displacement and velocity. Right. Next is acceleration. Now, acceleration is the rate of change in velocity. So if we take this A for acceleration, change in velocity is Vf minus Vi, and the rate of change in velocity means I need to divide that by time. Now velocity is a vector quantity, so acceleration, the vector quantity, acceleration, is also a vector because it depends on the velocity. So let's say I get into a helicopter. The helicopter starts off at a velocity of 0 and it ends off at, by the time it gets to school, it's going at 20 kilometers per hour, and it would take me, say, 5 minutes now to change 5 minutes into hours. I've got to divide the 5 minutes by 60. So 5 divided by 60 is 0.8 rounded off. 0.08, sorry, hours. So it takes me, the acceleration is 20 minus 0 divided by 0.08. So we're going to 20 divided by 0.08. So the acceleration is like that of a rocket, I think, is 250 kilometers per hour squared. Why is it per hour squared? Well, the unit for the velocity in this case is kilometers per hour, which can be written like that. Divide that by an hour, and if you know your mathematics, kilometer per hour comes from kilometers dividing by hours, so you change the division to multiplication, and then your exponent for hour will change to negative hour. So I'm changing this hours to multiply by per hour, so that is kilometers per hour squared. In the science class, we usually work with meters per second squared. It's just this example that I'm using as kilometers per hour squared. The next one is momentum. So momentum is the next example 3, 4, 5. Example 6 is momentum. Now momentum is the product of mass and velocity. Now, I know mass is a scalar, but velocity is a vector, so there is direction connected to it, so momentum is also a vector quantity. So momentum, the symbol for momentum is a little p, is mass times velocity. Right, so let's say my mass is 65 kgs and my average velocity was 20 kgs south. So get you 20 kilometers per hour south. So my momentum would be 65 times 20, which is 1,300 kgs per kilometers per hour south. Now, your book, because we usually use meters per second, will have momentum in SI units, kg, meters per second. So let's change 20 kilometers per hour to meters per second. 20 kilometers is 20,000 meters. An hour has got 3,600 seconds in it. So 20,000 divided by 3,600 will give you the meter per second. So it's 5 meters per second is my velocity. Okay, so 5 meters per second times 65 will give you the momentum. Sorry, 5.5. Or 5.56 if you want to round it off to the correct value. 5.56 times 65, so it is 361.4 kg meters per second south, because there is direction connected to it. Oh my, they're going in so much of grade 11 and 12 physics here. Example 7 is on impulse. Now, impulse is the change in momentum. So if momentum is a vector quantity, then impulse is also a vector quantity. Right, I wouldn't worry too much about it now. We will discuss it when you get to grade 12 one day. I hope this helps you. Please let me know if I can help you in any further way.